So this is section 7.4. It's a really easy section. It's called matrix operations. First thing you've got to do is know some definitions. So first thing is a row matrix. It's called a row matrix because it just has one row. A column matrix is called a column matrix because it just has one column, and you can see the examples below of the row matrix. That's a 1 by 3, and that's a 1 by 4. And then your column matrix, that's a 4 by 1 or a 2 by 1. I'm talking about the order of it or the dimensions of it. So equal matrix, if you have two matrices that we say they are equal, they have to have two things. They have to have the same dimension, and every element, position by position, is the same. So if you look at A, in example number 1, notice those have the same order. They have the same dimension. They're 2 by 2. They're both 2 by 2. But look at this very first one. I have a 2 in that position. Here I have a 1 in that position. So I know that these are not equal, even though the dimensions are the same. B, the dimensions are the same. And then if you look at each one, those 5s match, -7s match, -2s match, and the 4s match. So that's an equal, whoops, that should be yes. Those are equal matrices. Now, if you notice with this one, the 5 and the -7 is correct. Those match. But where you're supposed to have a -2 and a 4, we don't because it's not the same dimensions. So those are not equal matrices. So if you have been told that two matrices are equal, then that tells you that what is in this location matches what is in that location. So you can quickly figure out what x would be. 3 plus x is equal to 9, so my x is going to be 6. I'm going to go through and start trying to solve for each of these. Now, if I don't have a letter, then I don't need to do any solving. So I have a 4 and a 4, so I don't need to solve. But here I've got a t, and is going to be equal to 6. So that was really super easy to do. I didn't have to even solve anything. I just had to write it down. T equals 6. Let's try another one. How about that 5 is z plus 3. So 5 equals z plus 3. So that means my z has to be 2. That's supposed to be a z right there. Okay, let's look at the next one. That's 8 minus w is equal to w. So I'm going to set those equal to each other. 8 minus w equals w. So 8 is 2w. So my w has to be equal to 4. So basically, you're just getting lots of little equations to solve this. So I've got y plus 1 equals 9. So that means my y's got to equal 8. This one's pretty simple. -4 is p. So I'll just write it down. -4 equals p. So I also know that my q is equal to 3. Q is equal to 3. And my last one, let's see what I haven't used. I haven't used brown. Whoops, sorry. 2r is equal to r. 2r equals r. So that means that r is equal to 0, because if I subtract an r, get one r on one side and nothing on the other side. So I have all my answers to all my letters, and I did not have to pick up a calculator. Just wrote them down. Okay, so now we're going to do matrix operations. Okay, so matrix operations are, we call operations add, subtract, multiply, divide. All of that are called operations. You add two numbers, you subtract two numbers, multiply. Well, we have matrix operations. as well. So you do math on matrices. But there's a key. When you are doing math on your matrices, when you're adding and subtracting, you can only add matrices that have the exact same dimensions. Okay, they have to have the same dimension. So the sum of a matrix m times n, um, let's see, the sum of two m times n matrices A and B, um, you're just going to be adding, you're going to sum up the corresponding elements. For the difference, you're going to subtract. That's what all those fancy words are saying. So first thing we got to do is make sure that these are the same dimension. So if I look at this one, I notice that I have two rows and I have two columns. So that's a 2 by 2. Now let's look at that one. Is it a 2 by 2? Two rows, two columns. So they have the same dimension. So I can now add them together. So I'm just going to take each of these, 9 plus a negative 3. That's going to give me a 6. Whoops. Let's write it in brown. All right. I'm going to do the same thing this one. 4 plus 2 is going to give me 6. And then, let's see, blue, negative 8 and negative 4 is going to give me negative 12. And lastly, 2 and 7 is going to give me 9. So I just add each of the corresponding numbers, okay? Look at B. For B, I have two rows, one column. For the next one, I have two rows, but see, I have two columns, so you cannot do it. It can't be subtracted. Okay, you can't perform the operation because they aren't the same, they don't have the same dimensions. Okay, now we're going to talk about multiplying the matrices. There's two kinds of multiplying. One is called scalar multiplication, and it's just multiplying by a constant. Okay, um, so basically, I want you to think of distribution when you're doing scalar multiplication. So I'm going to take this 3 and I'm going to multiply it by that whole matrix. Okay, so to do that, I know I'm going to wind up with the same size matrix. Then I just multiply 3 by each one of those. I just distribute it 0, 3, and 9. And then 0, 3, and 6. And then, what's that? 3, 0, and negative 9. So I just distributed that 3 to all those numbers. Okay. I'm going to do the same thing to my negative 4. I'm going to distribute negative 4 to all of these. Notice I'm distributing the negative as well. So I'm going to wind up with a 4 and then my zeros, a 4 here and a negative 12. Now, some folks like to just distribute the 4 and then subtract. I just think that makes it a lot more difficult. I go ahead and distribute the negative, and then I'm going to just add these together, and I can add them again because they have the same, they have the same dimensions. So I'm going to add um, my 3 and my 4 together, and I'm going to get 7, and then I've got 0 and 9. So all I'm doing is adding everything in each of these. 3 and 4 gives me 7. That's going to give me a negative 6. This one's going to give me a negative 5. And then the last one is what? Negative 13. So I had 3 things I had to do. First, I distributed the 3. Then I distributed the negative 4. And then I added those two matrices together. And that is called scalar multiplication, when you multiply a constant by everything in the matrix. Now, to do matrix multiplication, that's multiplying by another matrix. So you're going to multiply two matrices together. Okay, now here is the key. When you multiply them together, two things have got to match, okay? Um, or you can't do it. Just like over here, we couldn't do this one. We couldn't subtract because they weren't the same. To do scalar multiplication, the only way you can do scalar multiplication is if when you write out your dimensions and you have this one that A had is a 2 by 2. This one is a 2 by 3. The only way that you can actually multiply these together is if these guys are the same. So basically, the columns of the first have to equal the rows of the second one. And when you do that, then your answer is going to be these guys. Whoops, sorry. The dimension of your answer is going to be a 2 by 3 matrix. Okay, so the blue ones have to match for you to be able to multiply. Okay, those guys have to be the same. Your answer is going to be the 2 by 3. As much fun as it is to do these by hand, because you have a calculator that does it, we're just going to do it in the calculator, okay? But first, before you start plugging stuff in your calculator, you need to make sure that you can do it, because it's a little bit time consuming to put these matrices in there. So first we're going to see if we can actually multiply these guys together. So we have AB. We have A is a 7 by 3. B is a 2 by 7. So I want to know if I can multiply A times B. So that means I'm going to have a 7 times 3. That's my A. And here is my B, is a 2 by 7. So the question is, are these guys the same? They're not. So you cannot multiply those together. Okay. Now, what about B times A? So if you're multiplying B times A, then your B is 2 by 7, and your B is 2 by 7, and your A is 7 by 3. Now look at those guys. See those 7s? They match. So yes, they do work. And what's your answer going to be? When you plug it in your calculator, your answer is going to be a 2 by 3 matrix. Okay? Let's look at this one, M and N. So my M is 3 by 4. My N is 4 by 5. Notice these guys are the same. So yes, we can do it. And my answer is going to be a 3 by 5 matrix. Now, NM means I'm going to write my N first, 4 by 5. My M is 3 by 4. Notice these guys. Are they the same? They're not. So you can't do them. All right. So in example number 6, first we want to see if it's possible. Look at A. A is a 3 by 3 matrix, right? 3 rows and 3 columns. So it's a 3 by 3. Now my B is a 2 by 3, right? 2 by 3. So can I multiply A times B? Can I multiply 3 by 3 times a 2 by 3? No, I can't do that. It is not possible. But for B times A, I can multiply a 2 by 3 and a 3 by 3. So yes, I can multiply that together. Now, how exactly do you do that? Well, you have to put A in your A matrix. I would suggest keeping the names the same. Put your B one in your B matrix. And then on your calculator, you're going to have it say A times B on your calculator and hit enter, and it will give you a 2 by 3 matrix. It'll have 2 by 3 matrix, okay? The way that you actually plug that in, you're going to look at it on this YouTube channel, because they go into great detail on how to actually enter those in. So you need to practice entering these matrices in and multiplying them, but I always want you to check and make sure you can do it before you actually start plugging everything in. And that is the end of this section.